Good morning or afternoon or whatever time you're watching this video. Welcome. We're going to look at a few word problems that can be solved using rational equations. We're just going to look at a few examples using a method that I like to use. I guess it could be called the box method or the chart method or the grid method. Basically, it's just a way of organizing our information in a way that we can see where the equation comes from that we're going to use to solve this question. So the first question we're going to look at talks about Jim and Bob. Jim and Bob, working independently, can paint a fence in 54 minutes and 81 minutes respectively. So 54 minutes for Jim, 81 minutes for Bob. How long will it take the two of them to complete the job if they work together? So let's organize our information. We know some stuff about Jim. We know some stuff about Bob. And what do we know? Well, we know their rate of work. We need to consider the time that they work and then the work that they accomplish. Because we know that rate times time equals their work. So Jim, we know that he can paint one fence in 54 minutes. So that's his rate, 1 over 54. And for Bob, he can paint one fence in 81 minutes. So that's his rate, 181. The question we're trying to ask is how long. So we don't know the time, but we know that they both work for some amount of time, t. And then we know that the work that they accomplish is just the rate times the time. So Jim's work can be represented as t over 54, and Bob's work can be represented as t over 81. And then we know that altogether they complete one fence, right? How long will it take for them to paint one fence if they work together? So in other words, Jim's work, t over 54, and Bob's work, t over 81, altogether equals one job done, one fence painted. And we're trying to find t. How much time did that take? So notice, in order to add these together, we need to get a common denominator. So we need to find the least common multiple between 54 and 81. That'll help us find the denominator that we can use to add these two fractions together. So 54, we know that that's 9 times 6, which is 3 times 3 times 3 times 2. So 54 is really 2 times 3 cubed. That's the prime factorization of 54. And 81, if we break it down, 9 times 9, that's going to give us 3 times 3 times 3 times 3. So we know that 81 is 3 to the 4th power. So the least common multiple, we need that 2, and then we need 3 to the 4th power. And if you do that in your calculator, 2 times 3 to the 4th power, 162. So that's going to be our least common multiple. So we're going to use that as our denominator here, 162. Okay. So what does 54 get multiplied by to get 162? We need another 3. So we really have 3t over 162. That's the same as t over 54, right? 54 times 3 gives us 162. And then 81 gets multiplied by 2 to get us our least common denominator. So this will be 2t over 162. So that's going to be 5t over 162 altogether equals that one fence painted. So in order to solve for t, we're basically just going to flip this upside down, right? We can multiply both sides by 162 and then divide both sides by 5. So that gives us our time is 162 fifths. Okay, so that's technically correct, but we're trying to answer how long, and we know that it's in terms of minutes, so we really want to divide this out and answer in terms of minutes. So 162 divided by 5, as a decimal, That's 32.4. So we can say 32 minutes and then 0.4 or 2/5 of an hour or of a minute. Well, 1/5 of a minute is 12 seconds. So 2/5 would be 24 seconds. So working together, they could do the job in 32 minutes and 24 seconds. Okay, let's look at our next example. This is a pretty similar one. It's about painting a fence. This time we have Joey, Phyllis, and Beatrice working together. Okay, so we're just going to set up another chart with Joey, Phyllis, and Beatrice all working together. And we're going to keep track of their rate of work, how long they work, and the amount of work that they accomplished by working for that long at that rate. So Joey can paint a fence in 3 hours, so his rate is 1 fence per 3 hours. Phyllis's rate is 1 fence per 7 hours, and Beatrice's rate is 1 fence per 4 hours. The question we're trying to answer is how long. So in other words, we don't know the time. So we'll just use T. T is the time that they work. So Joey's work is his rate times time, so he works for T over 3, or his amount of work is T over 3 fences painted. Phyllis's work is T over 7, and Beatrice's work is T over 4. And we know that altogether this work adds up. If we add those all up, we get 1 fence. So again, we need to find a lowest common denominator so we can actually add these all up. So we're trying to find the least common multiple between 3, 7, and 4. Well, if we look at 3 and 7, those are both prime numbers, and 4 is 2 times 2, so it doesn't have anything in common. So what mathematicians call that is relatively prime. 3, 7, and 4 are relatively prime to each other. They don't share anything in common. So in other words, their least common multiple is just going to be their product. 3 times 7 times 4, which if you do that in your calculator, 3 times 7 times 4 is 84. So that's going to be the least common multiple. So let's just rewrite each of these with a denominator of 84. Okay, so Joey was 1 over 3, or T over 3. So in order to get it over 84, we want to do 7 times 4. Right, we've already got the 3. We'll do 7 times 4 is 28. So Joey's work is 28 times time over 84. For Phyllis, she was T over 7. So if we consider that we already have the 7 here, what do we have left? 3 and 4 is 12T. 12 over 84 reduces to 1 over 7. And then for Beatrice, T over 4. So she's already got the 4. She needs a 3 and a 7 is 21 T over 84. 21 over 84 reduces to 1/4. Okay, so we've got everybody's work represented with a common denominator, so let's just add them up. We've got Joey plus Phyllis plus Beatrice over their common denominator of 84. 28 plus 12 is 40, plus 21 is 61 T over 84, and that equals 1 fence painted. So again, using our properties of proportions, right? If we multiply both sides by 84 and divide by 61, we'll get T all by itself. So T equals 84 over 61, or 1 and 84 minus 61 is 23. 1 and 23 over 61. And if we look back, we notice that our units was all in hours. So this time is in hours. So we could say 1 hour. And since 61 is so close to 60, we'll just say it's about, the time is about 1 hour and 23 minutes. approximately. Right, if you did 23 over 61 in your calculator and then multiplied that by 60, you'd get 22.6 minutes. So we can just round it to 23. Around an hour and 23 minutes if they all work together. Okay, we'll do one more example. This one's just talking about a generic job that Jeremiah and Isaac are doing working together. This one's a little bit different, but if we just use the same method to organize our work, we can solve it in the same way. So we've got Jeremiah and Isaac working together. And then so we need to talk about their rate, the amount of time that they work for, and how much work is accomplished. Okay. Jeremiah and Isaac working together are able to complete a job in 5 hours. So notice what we're actually being told here. We're being told the time that they actually work together. Okay. If it takes Jeremiah 9 hours to complete the job on his own, so we're told Jeremiah's rate is 1 job in 9 hours. How long will it take Isaac to complete the job independently? So in other words, we don't know Isaac's rate. We know that he would complete the job in H hours. We don't know how long Isaac would take. But working together, they could do it in 5 hours. So if they work together, the time will be 5 hours. So if they work together to complete one job, Isaac will complete 5/9, and Isaac will complete 5 over H. And altogether, if you add those up, you'll get 1 job completed. Okay, so this is what we're trying to solve. 5/9 plus 5 over H equals 1. Subtract 5/9 from both sides, you'll get 5 over H equals 4/9. Okay. You can use your laws of proportions to solve this. If you could cross multiply, get 4H equals 45. So H equals 45 over 4, or 11 1/4, or 11.25, or was it hours or minutes? Hours. You can also say 11 hours and 15 minutes is how long it would take Isaac. That's how many hours it would take Isaac working all together. And this one's pretty easy to check your work. If you just do in your calculator 5/9 plus 5 over 11.25, if you just add those together in your calculator, that does equal exactly 1. Okay, I think I skipped a part in this one. What percent of the fence will Joey paint? What percent of the fence will Joey paint? So if we look back at Joey's work, T over 3, right? We know that that's a portion of 1. Now that we know T, 84 over 61, we can say that Joey's work is T over 3. So if we do 84 over 61 all over 3, right, that would be 84 over 61 times 1/3. We know that 3 is a factor of 81, and if we factor it out, we'll have 21 left over. So 21 over 61. And if we just do that division, 21 divided by 61, 0.344. So about 34.4% is how much of the work Joey is responsible for. And that just goes back to our chart. We already knew the expression for Joey's work, and once we found T, we could just plug in T, and solve and find that Joey was responsible for 34.4% of the work. So a little bit more than 1/3. Good job, Joey. Okay, so that's all I have to say, those 3 examples. You'll have a few more on your problem set as well as on the study guide. So good luck. If you have any questions, don't hesitate to send me an email.